Okay, this is a worked solution to exercise 506, question 15a. They asked you to graph y equals x squared log x. This is a bit of a tricky one. The first thing to notice is with log x is always have to be positive. X is greater than 0. That's the domain of the function. That's really important. So there's not going to be any negative values to be considered. It can't even equal 0. Log 0 doesn't exist, so it can't even equal 0. Here's my first derivative and factorized. My second derivative is there. To find my stationary points, you can read through the working. I found one here. And here, x equals 0 and there. But x equals 0, when I put that back in, it doesn't exist. So there's not one x equals 0. If you look at the graph on Desmos, you'll see that it looks like there was about to be one. But it doesn't actually exist at 0. Okay, to determine the nature, it is a minimum at this one. You can read through all that working on the still shot. Point of inflection, I did find one at this point. Checked for change in concavity, and yes, it was a point of inflection. I've just noticed I never found the y coordinate on that. I will add that in before I post the still shot. There are the intercepts. When x equals 0, it doesn't exist. When y equals 0, we've got x squared equals 0, or x equals 0, or log x equals 0, which is when x equals 1. So let's put all that information on the graph. So I'll start with the intercepts. So we had an intercept. We sort of got one at 0, but it didn't exist at 0, so I won't put that one on at this point. Actually, I will. There's not an intercept at 0, 0. When y equals 0, sorry, that was that one. The other one was at x equals 1. I might put that over here somewhere. Okay, we had a minimum turning point when x equals about 0.6-ish, so about there-ish. And the y coordinate for that was negative 0.18. I'm going to put that right down here. So I'm going to mark my minimum there. I'm just going to write the exact form there. So it's 1 over root e and negative 1 over 2e is my minimum. My point of inflection was when x was about 0.22. So that would be a little bit less than a quarter of the way. It's about there. So what we can see here is we will have concave up there. Concavity doesn't change anywhere other than that. At this point, concavity is down, and it actually looks like that. Comes down to a minimum there and keeps going up after that.